So, for the people listening to the recording, this is a repeat. We talked about normal distribution, we talked about the Z-score formulas. Z-score formulas are only good if you're talking about entire populations. You cannot use that formula when you're talking about samples. So instead, when we talk about samples, we work with confidence intervals. And the idea is when you, if, for example, on your stat project, if you come up with a mean of your sample, that's not necessarily the mean of the entire population. We know the mean of the entire population is hopefully similar, but we create a range of numbers where that mean may fall. The really cool app that I have that I can't show you, that annoys me by the fact that I can't show you, I'll see if I can redraw it for you. It's got a normal curve and it's got a line. And it shows you, it does like, you can tell if you do 20 trials or 50 trials, but what it does is it takes and it makes little marks and it goes, okay, the sample mean ended up being here, and it shows you where the confidence interval range would fall. And then maybe the next sample, maybe the mean was over here, and it shows you where the range would fall. So it's showing you that every time the sample mean doesn't have to fall exactly where the population means. And maybe sometimes it's wacky, crazy off, and maybe even your confidence interval doesn't actually get the real mean inside of it.
So that means for your data, doesn't mean your data is right.
It doesn't mean your data is right, you're just accepting when you do samples that it may not be perfect. Now, I drew fairly small ranges here. That would mean that I was not sort of trying to have a super high level of confidence. That would be like maybe I wanted an 80% level of confidence. If I said, oh, I want to be 99% confident, then this range here, instead of being that far, 99% confident, would have maybe had a much longer line so that it encompasses more area. That guarantees you're more likely to have the real population mean in it. It's going to give you a bigger range because of it. So our goal is to figure out how do I come up with that range? How do I find that range of numbers? There's actually a statistical method. When you find that you're going to get a sample mean, you are then going to calculate how much to go on either side of it, and that's called the margin of error. Now, you should have, if you've been listening to the news at all lately, in the last month, you should have heard the word margin of error coming out. When they're talking about what? The election polls. Every time they give you an election poll, I was looking at them yesterday out of curiosity, and there's some polls that have Orman leading Roberts 48 to 47%, but the poll has a plus or minus 3% margin of error. What does that mean? It could be off by 3% either way. So if one of them's sitting at 48%, he could really have 51%. He might have 45%. It could be off that far. So when they're only a point apart in percentages, and there's a margin of error there, we really don't know who's going to lead at present. Yeah.
The interquartile range like for it?
Well, not exactly. The interquartile range is taking the middle 50% of the data. This is actually calculated based on a normal curve. This is how we come up with this range of numbers is based on a normal distribution. So, margin of error, which we will, margin of error we're going to represent with a capital letter E. So you're going to be calculating the margin of error that can be on either side of the sample mean. So this would be a sample mean, and you're going to calculate how much the margin of error is. And once again, it depends on how confident we want to be. If we're going to use our normal curve, we're going to use a different number if we want to be 80% confident as compared to if we want to be 95% confident. We're going to get a different Z-score out of our table. So the Z-scores aren't going away, and your table is still in use. Your table is still in use to the whole end of this year. So, technically, then, we're saying that we get our confidence interval by simply taking our sample mean and putting the margin of error on either end of it, either side of it, to get a range of numbers. Actually, calculating the confidence interval directly is not that difficult. There's a nice little set of steps here we're going to use to do it. Can I switch screens?
That's the formula.
That's part of the form. It's about some of these
Oh,
three
okay.
steps again, so don't play it, because it's the third step.
Okay, hold on.
Hold on. Oops, I hit you now, sorry. Alright. These are your three steps to find a confidence interval. Should I worry about all the hacking and copying that don't fake? No. That's usually the signal going across the room.
Not that sophisticated.
Yeah, I don't think I Okay, the worst part of this is step one, because they named it a silly name that confuses people. By long terms, it's called the standard deviation of the sampling distribution. That's its full name.
I think that's renaming it, like a half of these terms.
Yeah, okay? But the short name that we actually call it when we work with it, and that doesn't help, it still causes confusion. Sorry to say. The name I'm going to call it all the time is the standard error. It's called standard error of the mean. But it really is a version of a standard deviation. There's a nice little formula here, so don't flip about it. It's just that the name does not help you remember what it is. That's what I don't like about it. Okay. However, the symbol does help you remember. Symbol for standard error of the mean. Since it's related to standard deviation, is our good friend the whistle, with a subscript of the X bar, the mean symbol. So it's the standard error of the mean. That's the symbol for it. Okay. How you calculate it is relatively simple. You're supposed to take the standard deviation and divide by the square root of n. What was n?
Number of
trials.
Yeah. In your case, it's going to be the number you sample. Did you sample 20 guys? Did you sample 50 people? Did you sample 100 people? So, actually, I should have just written down sample size. Would be better, huh? Okay. Okay. Now, here's the deal. That sigma is the population standard deviation. You've just conducted a sample. Do you think you're going to know the standard deviation of the entire population?
Probably not.
Probably not. Most of the time, you don't know the standard deviation of that population unless it's been studied by some other means for some other reason. So we barely know sigma. So instead, they change it to just be S over the square root of n. What was S? The sample standard deviation. The standard deviation of your sample. So, but they put a stipulation on it. It's okay to use the standard deviation out of your sample if you sampled 30 or more items. So you have to, it's okay to use this if you use sample 30 or more people. Say cows, whatever. We're not going to do a cow problem.
That's quite popular.
Yeah, it seems to be quite popular. So, okay, use that standard deviation if you did 30 or more. Okay. You're going to go calculate standard or error. It's kind of like a Z-score. It's just a number you're going to use in a formula. Step 2, you're going to calculate the margin of error. This is what we really care about. Okay, margin of error is E, capital E for margin of error. And you take your Z-score times your standard error of the mean. So you calculate it in step 1. That's why I told you about stats. It's so simple today. Because mathematicians are lazy. Okay. But we have to know. Well, how can I just say use a Z-score. A Z-score that comes from where? Is it out of the thin air and saying use a Z-score? Yep. Okay. It comes from how confident you want to be. Whether you want to be 90% confident or 95% confident. So, I'll give you a quick example. I'll do an easy one, an easy number here. If I said do a 90% confidence interval, that means you want to be sure 90% confident that the population mean is in your range of numbers. So that means you want to get the middle 90%. And then you're going to figure out what Z-score am I at to get 90%. So they're going to give you a percent confidence. You're going to go find that Z-score using your table to get it. So you have to have that information. Then last but not least, the third step is relatively simple. You simply take, now you've calculated margin of error. Say the margin of error is plus or minus 5 points. Then you're simply going to put it on either side of the mean. So you're going to take your sample mean and you're going to add or subtract your standard margin of error. That's the formula you use back on the frequency. Yes, you may. You want to hear these words? Okay, I do not expect you to memorize these formulas. However, I will not tell you the steps in order. I will just have a list of formulas. They will be there. You have to know which one's what, but you don't have to memorize one. Alright, so now we're about to actually work a problem. Opposite of cows. Oh, I lied. No, cows is the next problem. First is wrestlers. Oh, I don't like that. I'm sorry, these are high school wrestlers. There you go. So you've done a sample. You found that the mean weight of 36 high school wrestlers is 106.4 pounds. Their standard deviation is 4.1 pounds. Okay, so first question, is it going to be okay to use this standard deviation? Okay, because this is the sample standard deviation. It's okay to use it. I said you had to have...
Yeah.
You had to have 30 or more. We have more than 30, so it's okay to use this standard deviation. Okay, and I want a 90% confidence interval. So you're going to do the 3 steps. What's the first step?
Find the
standard error of the mean. Usually we'll just call it standard error, which is the sample standard deviation over the square root of how many samples. 36. So how big? So what's the top number? 4.1. 4.1 is our standard deviation over square root of 36, which is how you're dividing by 6. And 94. That is in the formula. Pay attention. Okay. So your standard deviation of your sampling distribution, your standard error is 2.35. That's all you care about. Standard error is 2.35. Okay. Step 2 was to calculate the margin of error. And you have to have the margin of error formula. Because that's 4.1. Sorry. No. Right. Where's that number? When you were writing that, you're writing the 2.35 because that's what you know. Okay. So, sorry for reporting people. The Z-score came out to be 2.35 based on using 0.45 out of column A. Multiplied it. You have to make this make sense. It's simple if you process what the symbols mean. You have a mean. You're saying there's 3.88 pounds of error on either side of the mean. So literally, they want you to put 3.88 on either side of 136.4. Okay. You have to get a range of answers. Do the subtracted one first. 136.4 minus 3.88.
132.52 to 140.52.
Okay, thank you. So the low side is 132.52. The high side, and I should put pounds on there. So 140.28. Yeah, so there's our confidence goal. We are 90% confident that the real mean of all wrestlers is in that range.
Why would people not do higher assumptions for the rule? Why does everybody do a high one?
Most of them do. Most of them are 95, 90, 95, 99. Sometimes, you know, they aren't. The problem is when you do a higher confidence, that range can get really, really, really big. And it sometimes like a huge range. Yes, because now we have to go backwards. This is the cattle one. I'm not stopping the video. It's just going to have to run all of them. You went out and you fed 81 head of cattle, a special diet. And over a 6-week period, cattle, 81 cattle were 81 cattle. They were fed a special diet for 6 weeks, and their mean weight gain was 105 pounds. With a standard deviation of 10 pounds. Okay, I'm throwing it backwards at you here. And this is going to bug you because of the word I'm about to put in here. It wants to know what's the probability a cow gained 102 to 108 pounds. Okay. So how can I be asking the probability? Why would I be asking the probability? It's your percentage. The same thing as your percent confidence. Exactly what it is. I have given you here the interval from 102 to 108. If they say probability, it means what percent confident are you? Okay. So if you draw a picture of this, it's, I know these cattle, mean was 105. This is saying where were they at 102 to 108. Now you're going to think, oh, this is where people want to go out, get out the old Z-score formula. Stop yourselves, you can't do it. Okay. Okay, what's the only other formula you've got that has Z-scores in it? Because in order to look up percentages, we need Z-scores. Margin of error equals Z instead of error. You're going to have to use that formula to figure this out. You have to solve for Z. Okay, you should be able to look at this and tell me, what margin of error we have here? How much are we varying off the mean? 3. Let's be varying 3 either way. The margin of error is 3. Okay. If I knew standard error, I could solve for Z. So you still have to do step 1. Then you'll have to go and solve for standard error, and I'm out of space over here. Standard error is standard deviation over how many through the number of samples. Square root of 81 or 9, and that comes out 1.111. Okay, so you're going to throw that in there. For some reason, they use standard error with 3 decimals, and they round everything else to 2. Don't know that.
3 divided by 1.11.
Yeah, 3 divided by 1.11. No, you can't talk to it.
Attention students, if anybody has any Silverware jackets or any other miscellaneous items, they're okay.
Great, thank you. So you now know the Z-score is 1.35. Can't you go to your chart and look up which column? The A. Z is 1.35. You need column A with 2 B's. Like that. So, yeah, I don't think I wrote this in here right. You'll get the percentage. You have to double it to get both sides. Okay, there are 3 problems on there that ask you to calculate sample size. I will put the formula on here because all you have to go is the formula and you can do it. Figure out the answer. So, if you want the sample size formula, which is just like a regular formula that we did, it tells you how big a sample you need based on what you want to study. So that's the actual formula. I'm gonna put an example on here just so there's one in this recording. If you want a 92% probability, and your mean GPA is supposed to be in the range 3.1 to 3.5, with a standard deviation of 1.4, what size sample do you need to get? So this is actually how they officially determine how many you need to sample based on the size of your population. So all you have to literally do is fill in this formula. I just gave you standard deviation is 1.4. Margin of error, if your range is between 3.1 and 3.5, margin of error, the mean's got to be at 3.3. So that means your margin of error is 0.2 points. So you're going to put margin of error in at 0.2. And then since I wanted 92% probability, you go to your chart, you want 92% in the middle, which means you need, for our chart, you'd have to do 46% in column A. And if you do 46% in column A, that turns out to be a 1.75 G-form. So you throw it in there, you calculate it, you have to remember to square it, so you can do that. It actually comes out 1.50062. On sample size, if there's any decimal, because you always want to sample too much, you should always round up, no matter how small. So this would be saying you should sample 151. So it's always rounded up, regardless of what it is. Sample size is not a major big deal.